Hey, hello everyone. It is me, John Park. Surprise, it's me this time. I'm hosting Show and Tell. I know we have a somewhat rotating cast of characters doing this. This week, it's me. So I'm excited to be here, and I am also really excited to check out your projects. So if you are interested in coming on Show and Tell and showing us maybe something you're working on, could be a work in progress, a completed thing, an idea, a dream, whatever you want. Come on and show it and talk about it for a couple of minutes here, and people can take a look. If you're looking for a link, we've got a blog post up, and we also have our Discord server. So if you go to adafruit.it/Discord, look for the live broadcast chat channel, and you'll find a link there, as well as a lot of people hanging out and having conversations. So first off, I'm going to bring on a couple of Adafruit people, and then we've got 2 or 3 people from the community to show their stuff. So they'll take a couple minutes to talk about their things, and we will probably get out of here a little bit early, so you'll have a chance to go grab a snack and a beverage before you tuck in for a Ask an Engineer episode happening at 8 o'clock Eastern time. So first up, we'll bring on Dan.
Okay, Dan. Hi. So I'm Dan. I work for Adafruit on the CircuitPython. I'm a core developer for CircuitPython, but today I'm going to show you a new board that's under development, and I wrote a little demo for it.
Cool.
So this board here, oh, we got really bad lag here. All right, hold on a second. Let me switch to video. Let me restart this.
Sure.
Okay, hold on a second.
Mm-hmm.
That's better.
Dan, you're one of those intrepid folks who uses Linux for this sort of thing, aren't you?
Yeah. So it's always dangerous.
Exciting.
Okay,
hey.
There we go. All right.
Nice.
Now you can see. So this board is green, which means it's a prototype board.
Mm-hmm.
And this is an Adafruit Feather RP2040 prop maker. Okay, so we have a Feather wing called a prop maker, and that's really for cosplay kind of projects that want sound and neopixels and has an accelerometer in it. And this board has all that stuff right on the board. This is in the Feather RP2040 Bones series. We have a bunch of boards that start with a core, kind of a core RP2040 thing, and then there's room on the board to add a bunch of other stuff. So in this case, there's an accelerometer, an LIS 3DH. There is an I2S amplifier, mono, that can drive a 1 watt or a 3 watt speaker, depending on the impedance of the speaker. There is a 5-volt level converted NeoPixel pin. There is power to the NeoPixel strip, and all those things are on screw terminals here, so you don't need to do any soldering.
Mm-hmm.
And there is a 3-pin servo connector, so you can connect up a servo, which wasn't true on the Featherwing prop maker. And there's also a spare I/O pin that you can use for a button for input or output. And you could also use the servo pin, control pin, as a regular old input output if you needed a spare one. And as you'd expect, there's a Stemma QT connector in case you want to connect up any other sensors or other I2C devices.
Yeah.
So what I've got here is a little demo. There's a servo underneath this thing up here. It's a servo like this, but it's all wrapped up in blue tape, so you can't see that. And this is another kind of speaker that you can use. We sell these speakers too. And so I have this set up so that if I lean the board to the left, the servo turns to the left, and I lean the board to the right, it turns to the right. And meanwhile, it's doing a little animation here. And if I press the button, then we get, I don't know exactly what this is, if this is a gun or something, or some kind of like.
I think that sounds like the honking goose.
Yeah, this is a sound I stole from one of our sword projects.
Sounds familiar. Okay.
So I made this without any soldering, okay? And it's on the breadboard, but that's just to show you, this very high class blue tape implementation here. But we hope this is not out yet, but it's under development and looks pretty good. And it should make it a one board, no soldering project for all these kinds of cosplay projects.
Yeah, and you could battery power all of this, right?
That's right. You can attach a LiPo battery right here on the Feather, and those power also go here. And also there's control of there's a special control pin here so that you can turn all the power to the NeoPixel strip and the amplifier on and off. So if you want to power the thing down temporarily, you can do that and still have microcontroller
save some battery life if you're using this as a prop or a cosplay thing.
Exactly. So we're really pleased with how this came out, and Limor managed to squeeze all this stuff in on this sort of 1-inch square of space here.
Yeah, it's like the whole feather wing of the old prop maker is now a 1-inch little tail on.
Yeah, great. It's great. Yeah.
Oh, I'm excited about it. Thanks for sharing the demo. Really cool. And I guess people should keep an eye on Ask an Engineer and our blog and the store to see when this.
Right. So the board definition is already in CircuitPython if you want to go look at the pins or anything like that. So Feather RP2040 prop maker is what it's called.
Fantastic. Thanks for the demo, Dan. Appreciate it.
You're welcome.
Bye-bye.
See ya.
All right. Next up, we have Scott. Hey, Scott.
Hello. Can you hear me?
I hear you great. What you working on? What's new?
Well, I've been doing a couple things. I showed Pico DVI last time, so that's checked in, and Dan just did a beta 2 release, so it should be in there. Heads up, it is going to change just a little bit because of feedback from todbot. So keep an eye on for that for the next beta. Just the frame buffer numbers you give it, which todbot doesn't know I'm going to do that yet, but he'll figure that out soon. The other thing I've been working on the IMX RTs. This is the 1015 board, and I figured out just yesterday about how to get CircuitPython running on that along with TinyUF2. So that's been good, and I'm also adding the ability to speed up the flash before as CircuitPython starts running, which will be cool too. I've got the 1020 here on my desk. I was just going to test them all, and it's not working, so I have more debugging to do tomorrow. But then the other thing I wanted to show is we got a report of e-ink. Oh, my thing is not quite long enough. E-ink displays not refreshing correctly. And somebody was kind enough to say, like, hey, it's because you're doing big endian addressing, not little endian. And so Limor suggested I make a demo that tests it. So this is that demo. So every 10 seconds, it refreshes and places a label in each corner. So it's doing partial RAM refreshes and making sure that those addresses that we're giving to the displays are correct.
Oh, good. And what's the practical effect for watching the refresh if someone's using the old method versus this? Will it?
So the old code just won't look right. Particularly, like the first refresh usually works because your numbers are like 0, and 0 is the same regardless of how you swap the bytes. But then subsequent refreshes, like it may blink, but it won't show your new data. For example, so there was actually this has been a long-standing issue. Anecdata filed some issues in 2019 that had this problem. So if you're using the SSD 1675, 1680 or 1681, you'll need to get latest and greatest CircuitPython and some new library code that enables the little endian addressing. And
hey, can you show us the board you were using for that?
Yeah, let me unplug it so I'm not constrained by so the green board here is a prototype of the Feather ink, and you can see it was designated for me, which is cool. It's just been super helpful. Like we had these breakouts, but with these breakouts you have to use a breadboard and everything. And I've started just I have a whole desk full of e-inks, and I just flip the ribbon cables out, and I use the same Feather for testing them all. It's really
that's excellent.
And convenient.
Ribbon cable, all the things. That's the new mantra. I love the the iSpy for SPI stuff and for e-ink. It's life is good when you don't have to do all that wiring.
Yep, just got to be delicate with it.
Yep. Great. Thank you, Scott. Appreciate it.
Thanks for hosting.
Okay, you bet. Take care.
Bye.
All right. Let's see. Next up, we have from the community, Micah is coming on. Hey, Micah.
Hello. So I know I've shared this project a few times before, but this time it's a little different because it's no longer just a design and a screen or even a half-working PCB. It now is a fully functional board, and it's almost ready to be sent around the world.
Ooh, cool.
I've simplified the design to make it smaller and less expensive, and because the previous version would have cost $35, this one's target price is about $20. There's a few problems with this version that I plan to work through, and there's a non-exhaustive list. There's a component directly under the battery connector. I'm not sure if you can see that. Right here, there's a transistor right under it, and when you unplug the battery, the transistor gets ripped off.
Whoops.
Which I learned the hard way. And the holes that I used to attach the wires, sorry, right here, right there. They're too small and too close to the edge. And the USB-C port, I actually had to trim this edge because it was too close.
Oh.
And you couldn't plug in the USB cord.
And for people who don't know, this is the haptic fidget spinner. Am I right?
Oh yeah, I'm so sorry. I should have given
no
an introduction.
Worries.
It's a haptic feedback fidget spinner. So it uses vibration motors mounted on the back to make it feel like it's spinning, but it's staying still. So
That's
sorry,
cool.
I should have introduced it first. But been working on it for maybe 4 months at this point. And also there's no low battery indicator. So when the battery starts to run out, it just starts to get less responsive, and you don't notice that that you don't know.
Right.
But there's a lot of good things about it too. It's AVR based, which does mean no more CircuitPython, which is very sad. But it means it's a simpler design. It can be smaller and have less power consumption. There are only 3 motors instead of 8. I don't know why I chose 8 last time. It was not a very good choice because it meant a lot more complexity and it had to be a lot bigger. But now there's 3, and it actually means you can tell which motor's on at any given time more precisely. So it actually feels like it's spinning more better. The buttons are quieter, which is kind of accidental. But they're quieter. So yay. And this is a big one for me. It didn't need any rework.
Congrats.
So I didn't have to solder any wires to it when I got it, other than the motors.
That's a triumph. Yeah.
And it's smaller, easier to hold, and all in all, I'm super excited to see what the future holds for it. And I hope it helps people around the world. It's not like life changing or anything, but I hope it helps some people reduce anxiety.
Yeah.
And of course, it's open source. You can download the design, both the CAD and the firmware from GitHub, and it's all under the MIT license. So.
That's fantastic. If people want to find out more right now, what's a good link for them to
I will drop one in the Discord.
Super. That's fantastic. Thank you so much, Micah. Congrats on the update. Take care.
Thanks. You too.
Very cool fidget spinner. All right. Next up, we're going to bring on todbot. He's already been name checked on this very broadcast.
Yeah, sorry, Tanut. But and I'll get back to that. But first, I would like to say I am super pleased that we have animated GIF support in CircuitPython now. I've been having tons of fun with it. So thank you, Gamblor, and other people who have worked on it. It's so cool.
That is fantastic. That GIF
and like you showed this like last time, I think, or in one of your shows. But this is doing some hacks, writing directly to the SPI of the display, so it's a little bit faster than you would normally do with display I/O. But awesome.
Oh my god! and this GIF it looks like it's almost like in a snow globe or something because of your round display.
Yeah,
it's bonkers.
Yeah. The round display really sells it. But the thing I worked on, so this is really not my work. This is all like your work and Gambler's work and other people from CircuitPython. But for the thing I was working on today is I was playing around with the HDMI DVI support that's now in CircuitPython. And let me bring in my picture-in-picture.
Let's enable that.
And so here's the Pico DVI board on a little tripler, and it's got a little thing here that's being used. This is a little like sci-fi display of just 768 display I/O objects just being turned on and off, sort of as a little, you know, bleep bloop bleep bloop computer display.
Right. Yeah.
Another little thing I got here is just to prove that it's actually CircuitPython. So here's something fairly similar, but this one is talking seesaw, I2C, to this little joypad, and so I can drive around this little emoticon spaceship with the joystick.
So cute. Oh, I love that. You've made an arcade game. That is so great.
So the reason why this is important to me is I was trying to get the seesaw, I2C stuff to work in the Arduino, in Arduino with the Pico DVI library, and it was just not working. There was like something weird going on where it would work for a couple seconds then crash or whatever. And so I'm trying to figure out what's going on there. It's probably something I'm doing wrong, but this in CircuitPython just works straight away, you know. So
that's cool.
So yeah, that's what I got.
I love that. What sort of resolution are you sending? Do you know, from like, the display to Tan Newt's point a little bit, like, because this is a
yeah. So it's all it's in CircuitPython. If you're doing any sort of color, it's 320 by 240. It's currently configured as 640 by 480 because that's what the monitor is actually getting. The monitor is actually getting 640 by 40. Every pixel is doubled. And I think that might be what's going on in the Arduino library as well. I need to go back and check that out because the Arduino library talks about it in terms of 320 by 240. Mm-hmm. But still, it's 320 by it's a display on a monitor.
Yeah, great. So someone over in the Discord just posted a nice GIF of asteroids. So I think that's a hint.
Well, if you recall, I've got that asteroid, that CircuitPython asteroids I did like 2 years ago,
right,
and I was starting to port that to a no solder solution. You just put the Feather DVI and this little joystick on a doubler, and then you've got a little arcade box that can control a TV.
That's wild.
But I was running into problems in Arduino, so thankfully CircuitPython works.
On over to the CircuitPython side. Thanks so much for bringing your updates on. Very exciting. Love seeing the DVI Feather stuff. It's amazing. Really cool.
Cheers.
All right. Thanks. All right. And last up, we've got Mark Gamblor. Hey, Mark.
Hey. So the project I've got this week all started when I needed a new fan for my computer, which resulted in me going to the store and buying a new video card because I was there. And then finding out the video card would not fit in my current case.
Oh, this is familiar. Yeah.
Yeah. So long story
days.
short, I eventually had a new case with RGB lighting on the fans.
Oh, yeah.
And I thought I need to control these.
Oh, goodness.
So what I found out was that it's basically NeoPixels that are in all the modern fans.
Okay.
But my motherboard couldn't drive them. So I was like, this should just work with CircuitPython and most of the boards I've got. But what it wouldn't do is there's the Scorpio, which is great if you want to control a lot of NeoPixels, but it can't connect anything. And there's lots of NFR chips that are great for Bluetooth, but they don't do the level shifting. Though the itsy bitsy I did find out about after I did all this work.
Oh, because it has that 5 volt. Yeah.
So I have now designed this board, which is basically an NRF 52840 chip. But it's doing the level shifting up to 5 volts for all the addressable RGB fans in my case. So while I'm showing this, I'm trying to move my webcam over so I can show. There's the case with all the fans being controlled.
Oh, that's cool.
So like the Scorpio, there's 8 different outputs. So, and I made them all the size so you could plug each individual strip that you've got in your case into it. And then let's hope this is still connected through the File Glider app that Adafruit has. I can save. Let's see if it restarts.
Yeah.
Yeah. And without having to open my case at all, I can change the code.
That's awesome. That's really cool.
So yeah, this all worked out better than expected.
Just because your fan broke.
Yeah, well, because my CPU was overheating and my fan broke, I ended up designing a new
Next thing you know,
PCB.
you're designing.
Yeah.
Oh,
So
love that.
now this can just sit in my case. It can control everything. Right now, I can use File Glider, edit remotely. I might actually just make a little Bluetooth controller or something, but yeah.
And are you powering that board off of case power, like a 5-volt rail?
Yeah, so they actually did have the top right connector is actually just 5 volts that came out of the top of the case. I just found it and realized it had 5 volts. So yeah, it's all self-contained. You don't need to run a USB cable either internally or outside. So it works really well in that way. And then it distributes the power throughout the board. Yeah.
Excellent job. Very cool.
Thanks.
I love the lengths you went to, and it's well worth it. And that's a cool looking case too. Got all sorts of
Thanks. Yeah, I figured since I was already so far in the hole with everything, why not?
Double down.
Now maybe I'll just throw some NeoPixel strips around the edge.
Yeah,
edge where it goes from there.
More interior lighting. That's fantastic. You've got what, 3 more strips you can plug into your board there, right?
Yeah, and I could move the power around too, or figure something out. But yeah, actually the only thing right now is the one of the resistor kits isn't quite soldered correctly because I mean it's pretty zoomed in there, but I didn't quite realize how small those were. And trying to solder those by just a hot plate was exciting.
Challenging.
Yeah.
Well, great work. Thanks for sharing that. I appreciate the lengths you went to, and I love the creative stuff you bring on each time. So thank you, Mark.
Yeah, thanks a lot.
All right, take care. All right, well, thank you everyone for stopping by with your very cool, very interesting projects. That was a lot of fun to check out. People are chatting about stuff over on our Discord. If you want to go check that out and hang out, drop in any links and things, and answer any questions, that would be fantastic. Now you've got about 7 minutes to go grab a snack and a beverage and get ready for Ask an Engineer, which is happening at 8 o'clock Eastern time, right here on your favorite Adafruit broadcast channel network thing. For Adafruit Industries, I'm John Park. This has been Show and Tell with everyone from Adafruit and the community joining in. We appreciate it so much, and I'll see you next time. Bye-bye.